Here it is, part 2, antiderivatives. Let's do some examples. All this one's going to be, just going to do a few. Make sure we got these concepts down. This is more about you getting in and checking out these patterns, making sure you can't be tricked, seeing the basics, so we can be ready for doing things like called U-subs. A little bit more challenging things. So let's build up. Bang, we got 4 of them. First 2, straightforward. No big deal. So we're going to write this thing in. We'll say that our big F, right, the antiderivative, and F5's not going anywhere. F5 just stays right there. But now we're going to take our x and we're going to add 1 to that exponent, right? So that's going to become a 5, and then we divide by that number. Fortunately, the 5's just cancel out, and we can say our big F of x is equal to x to the 5th. Oh shoot, I think I forgot something. Gosh dang. I better put a plus c in there. There could be a constant. Alright, so what is the derivative of x to the 5th plus any number? It's 5x to the 4th. You get to check your answers through antiderivatives. That's dope. You haven't really been able to do that since frickin' algebra. Let's go to our next. Let's go get big G of x. What's the antiderivative of secant squared? Or ask yourself, what has a derivative of secant squared? You don't know? Get out. Unless you just brain farted, then you can come back. But you gotta know that, right? It's tangent of x. Plus or minus some sort of constant, so let's just write plus c. Let's just write plus c. It's always plus c. You can write minus c if you want. Continuing on. We go down to our h of x. Now let's rewrite this real quick. H of x. Now we're going to use this constant multiple rule. This is the same thing as 2 times 1 over x, right? Just like where we had the 5 from up above right there. That constant's just going to go along for the ride. So let's go get our antiderivative. Big H. So that 2, it's just coming along with us, huh? It's just going along. Now, what is the antiderivative of 1 over x? And this might be one of those, and you're like, all right, well, x to the negative first. I add 1 to it, and you get a 0. That means stop. Freaking stop. That's not the right thing. So if you get a 0, you sure as hell aren't going to be dividing by 0, are you? Do you think you're really going to be freaking dividing by 0? Get the hell out of here with that nonsense. You know what I mean? So let's call this, what has a derivative of 1 over x? The natural log. But I told you in class before that no longer, we got to get this absolute value in there because the x's could be negative. We can't have any negative values. Shit, we can't even have 0 in there, but we wouldn't have been able to have 0 there either. We write in plus c, so our big h of x is equal to 2 times that natural log of the absolute value of x plus c. You lose that absolute value, all of us math teachers will smash you for it. And now we get to number 4. Again, this one's relatively straightforward as long as you recognize it. My big T of x. You're like, what has a derivative of 1 over 1 plus x squared? And again, we got that word tan, but this is tangent inverse of x. And don't forget your plus c. Antiderivatives, dude. That's what we do. Cool. Let's go find some more. Now these are a little bit more interesting. These have some work that might be needed before you go right through because we don't have any rules. We don't have any of these other tactics like this right here. Doesn't that look like a chain rule or something? Well, if it looks weird, the only thing we know for right now is a power rule, and we know a few like, excuse me, and a few trig things. So why don't we expand that thing out so we can use our power rule? So if you take x minus 3 all squared, of course it's not x squared minus 9. We know better than that. It's going to be x squared minus 6x plus 9. Well, shit, now that's something we can take an antiderivative on. We can just go term by term. This is wonderful. We go, all right, big F of x. Well, let's play that game. So we're going to add 1 to that exponent, so it's going to become x cubed. And then we just divide by whatever that number is. Now we got our 6 times our x to the first. So we're going to add 1 to this, and that's going to become 2, and now we divide by that number. Now let's go to the next one, and let's write this one in. You didn't know it was there, but this is x to the 0th power, right? It's always hanging out there. That's a 1. What happens if you add 1 to this exponent? You get 1, and then you divide by it. So the only thing you're going to be left with is just 9x. Because what has a derivative? I'm going to remove that. What has a derivative of 9? 9x. What is a slope of 9? The freaking line, 9x. And that's why that happens now. Just don't forget it. We got a little plus c at the end. And plus we need to clean it up. I prefer to write it as 1/3, but I'm a weirdo. Minus 3x squared plus 9x plus c. And I think that this might be a sufficient solution. You take a derivative on this thing, you're going to find out you get right back to where you started, probably just without the factor. And let's deal with number 2. And I don't think you've been paying attention if you don't see the trick to this one. I harp on it, I ragged on it in class, I put it on tests, I made fun of you when you did the quotient rule on it. I beg you not to do this. And let's just break up that dang numerator. Let's do some algebra. Oh, by the way, this is equal to x to the 1/2 power, so this is 2 over x to the 1/2 plus x over x to the 1/2 minus x squared to the x to the 1/2. So what's this? 2 times x to the -1/2 plus x to the 1/2 minus x to the 3/2, right? Because you got 4 halves up top minus 1/2, that's 3 halves. Let's get it. Let's go find that general antiderivative. So we say big old G of x. So now we are going to leave this 2 alone, and we are going to add 1 to -1/2. What is -1/2 plus 1? That's positive 1/2, but now we need to divide by 1/2. I'm only going to do this once because this is a bad idea. Dividing by 1/2 is the same thing as multiplying by 2. So instead of dividing, why don't we multiply by the reciprocal? Dividing by a number is the same thing as multiplying by its reciprocal. So why don't we just multiply by 2 and give it another one? Let's play this game one more time. So we're going to add 1 to the 1/2. 1 plus 1/2 is equal to 3 halves. And instead of dividing by 3 halves, let's multiply by its reciprocal, 2/3. Here we go on our last one. We got to add 1 to 3 halves. That's 5 halves. Now let's not divide by 5 halves, but let's multiply by its reciprocal. And don't forget your plus c. So our cleaned up solution could be 4x to the 1/2 plus 2/3 x to the 3 halves minus 2/5 x to the 5 halves plus c. And there's your big old G of x. There's some antiderivatives with a little bit of algebra in it. We'll see you for the next one for some particular solutions.